we'll continue further into the chapter of matrix for standard 10. We have already discussed what is a matrix. We have discussed the kinds of matrix. We have discussed the transpose of a matrix. We have discussed the first operation, that is addition of matrices. Now the second operation on matrices is subtraction of matrices. Subtraction of matrices is exactly the same as addition of matrices, and it is only possible if the two matrices are of the same order. If they are of the same order, then we can add them or we can subtract them. For example, I have written two matrices. One is A 5 4 2 1. This is of the order 2 into 2. We told you what is the order, number of rows into number of columns. It has got 2 rows and it has got 2 columns. Similarly for B, I have got 2 rows and 2 columns. So both matrices are of the same order. That is why subtraction is possible. Like we can add also A and B. We can subtract B from A or A from B. Let us see A minus B. A minus B. We do exactly the same as we do addition, because subtraction is also addition with an opposite sign. 5 4 2 1 is A minus 3 0 4 2. Even I can do that if you like. I can show it and make you understand this one. 5 4 2 1. I'll make it plus here. I'll make it instead of minus plus, and this minus will go inside with each term. Minus 3, 0 plus or 0 minus does not matter. Minus 4, minus 2. Now when we add these two matrices, obviously what will you get? 5 minus 3. Corresponding elements are added with the signs. 5 minus 3, 4, minus 0 or plus 0 does not matter, 2 minus 4, and 1 minus 2. So what I get is 5 minus 3 is 2, 4 minus 0 is 4, 2 minus 4 is minus 2, 1 minus 2 is minus 1. So we get A minus B as 2 4 minus 2 minus 1, and it is of the same order as the two original matrices were. A and B were of the order 2 into 2. So A minus B is also of the order 2 into 2. Now suppose I want to calculate B minus A. Suppose I want to calculate B minus A. So B minus A means first I'll write B 3 0 4 2, and then minus 5 4 2 1. If I subtract, 3 minus 5 is minus 2, 0 minus 4 will be minus 4, 4 minus 2 will be 2, and 2 minus 1 will be 1. Now you will realize that A minus B is not equal to B minus A. A minus B is not equal to B minus A, while is A plus B was equal to B plus A. And that is why we said that commutative property was followed by addition of matrices. But here A minus B is not equal to B minus A. Let's take another example and show it to you. For example, A is 5 4 3 minus 1. B is 2 1 0 4. 2 1 0 4, and C is minus 3 2 1 0, minus 3 2 1 0. Now he wants us to calculate A plus B minus C. He wants us to calculate A plus B minus C. A plus B minus C. So we will write like this. The matrix A is 5, 4, 3, minus 1 plus 2, 1, 0, 4 minus 3, 2, 1, 0. Now what we do is, we again we'll take the minus sign inside. You can do without that also, there is no issue in that, but it will be easier for you to do it that way. We will take the negative sign inside, make it plus 3, minus 2, minus 1 and 0. Five plus 2, 7 plus 3, because minus has become plus. So 5 plus 2, 7 plus 3, 10. Then I have 4 plus 1, 5. 5 minus 2, 3. Corresponding elements. 3 plus 0 is 3 and then minus 1. It is 2. Minus 1 plus 4 is 3. 3 plus 0 is 3. So this is the final value of A plus B minus C. So it contains addition as well as subtraction of matrices. And this is only possible when they are of the same order. If they are of the same order, then we can find the matrix. For example, let's take another example where we will discuss the transpose of a matrix and the matrix. We told you what a transpose of a matrix is. That if we interchange the rows and columns of a matrix, it becomes its transpose. Matrix A is given as 2, 1, 3, 2, 1, 3, and it is given as 4, minus 3, 2. 4, minus 3, 2. This is the matrix A. And the order of this matrix is number of rows into number of columns. There are 2 rows and 3 columns. So, when I will find the transpose of this matrix, I'll get A dash or AT. I'll get 2, 4, 1 minus 3 and 3, 2 as A transpose. Now it is not possible for us to add A and A plus T, AT. We cannot add or subtract. We cannot add A to transpose of the matrix because here the order is 2 into 3, but here the order is 3 into 2. So the order of the matrix A and AT are not same. Order of matrix A is not equal to order of matrix AT. Hence, addition or subtraction of A and AT is not possible. It is not possible because we told you that 2 matrices can be added or subtracted if they are of the same order. Here the order is 2 into 3. Here the order is 3 into 2. That is why the matrices cannot be added or subtracted. The next thing which I have to discuss in this topic is additive identity. Additive identity. What is additive identity? What is additive identity? Additive identity in matrix will be that if we add something to the matrix and matrix remains unchanged, then that quantity which is added to the matrix is called additive identity. For example, I have a matrix A. For example, it is A, B, C and D. This is a matrix of the order 2 into 2. It's a journal matrix I have taken. And if I add a null matrix to it, I can add a null matrix also of the same order. Suppose B is 0, 0, 0, 0. This has to be of the same order. Then only we can add A and B. Then only we can add A and B. So A plus B will be A plus 0, B plus 0, C plus 0 and D plus 0. If I add 0 to A, it remains the same. That means A, it becomes B, it becomes C, it becomes D. That means when I added 0 to it, when I added the null matrix to it, the matrix remained the same as A. The matrix remained A only. A is A, B, C, D, and if I added 0, 0, 0, 0 to it, the final answer was the same as matrix A. So B is called the additive identity. B is called additive identity. And additive identity in case of addition of matrix is the null matrix. B is a null matrix or zero matrix where we realize that all the elements of the matrix are 0, 0. Now let us see additive inverse. What is additive inverse? Let me take the same example, that is A is A, B, C, D, and let me take A to be minus A, minus B, minus C and minus D. If I add A and B, suppose I add A and B, I will get A minus A, B minus B, C minus C, D minus D. It will be what? 0, 0, 0, 0. Or if I find out B plus A, it will be also 0, 0, 0, 0. So if it happens that on addition of two matrices, we get the answer as 0, as a null matrix, not 0, null matrix. It is a null matrix. If the answer comes out to be a null matrix, then we say that B is the additive identity for A, or A is the additive identity for B, because additive inverse. Identity was a null matrix. It is the inverse, additive inverse, because by adding B to A, I get the answer to be a null matrix. So B is the additive inverse of A and A is the additive inverse of B. Okay, thank you. Morning, class 11th. We are continuing our journey into trigonometric functions, and now we have come to the problems on trigonometric identities. You have already done very tedious problems in class 10th also of identities. We will be doing some more problems on trigonometric identities. There are n numbers of trigonometric identities and problems are there. I'm going to do few for you. Basically, you have to, as we keep telling you, trigonometry is a manipulative thing. You have to manipulate in trigonometry to get your answer. Left hand side will be given equal to right hand side. It has generally been told, must have been told to you, that we pick up the more complicated side, start from the more complicated side and come to the simplified form. Like in the first question, it is, if you look, I have sec alpha under root 1 minus sine square alpha is equal to 1. So I cannot start from 1. I cannot start from 1. What I have to do is I have to start from the more complicated side, that is left hand side, sec alpha into under root 1 minus sine square alpha. Now you know the basic identity, the first identity, that sine square theta plus cos square theta is 1. Sine square theta plus cos square theta is 1. So cos square theta will be 1 minus sine square theta. Instead of theta, here it is given alpha. 1 minus sine square alpha. So in this I can write cos square alpha. I can write cos square alpha. Then it will become sec alpha. When you take the under root, it will become cos alpha. It is cos square alpha, so it will become cos alpha. And then you can change, sec is the reciprocal of cos. I can write 1 upon cos alpha into cos alpha. This cos alpha will cancel. We'll get 1 as the answer. So we have been able to start from left hand side and go to right hand side. Left hand side was sec alpha into 1 minus sine square alpha. Applying some basic identities, we were able to get to the right hand side. So from sec alpha into under root 1 minus sine square alpha, I've been able to prove it is equal to 1. Now let us see the next problem, second one. Second one is almost same, sec square theta minus 1 minus tan square theta is equal to sine square theta. Again, the left hand side is more complicated, so we will start from left hand side. Because sec and tan are involved, you know sec square theta, you know the identities, sec square theta minus tan square theta is equal to 1. Sec square theta minus tan square theta is 1. So what I can do is, it is equal to 0, not sine square. So I'll combine sec square theta minus tan square theta and minus 1, starting from left hand side. Starting with left hand side. Sec square theta minus tan square theta is 1. So 1 minus 1 is equal to 0, which is right hand side. So from left hand side we get the right hand side. Whatever was given left hand side is proven equal to right hand side. Let us see the third problem. Sine 4 theta plus sine square theta cos square theta is equal to sine square theta. What we are going to do is, let's take left hand side. On the left hand side, it is sine 4 theta, sine to the power 4 theta plus sine square theta cos square theta. Out of this I can take out sine square theta as common. If I take sine square theta as common, what will be left? Sine square theta plus cos square theta. Because out of sine 4 can be written as sine to the power 2 into sine to the power 2. Out of that one, sine square has come out common. Here sine square has come out common. So here it will be left sine square theta plus cos square theta. and sine square theta plus cos square theta is 1. So your answer will be sine square theta, which is your right hand side. So we are going from left hand side to right hand side. We start solving, applying basic identities and try and solve it like that. Now let us see fourth question. You have to remember all the identities. You have to remember all the identities. In trigonometry, the formulas have to be remembered. Fourth one. Sine 4 theta plus 2 sine square theta cos square theta plus cos 4 theta is equal to 1. Again, we will start from left hand side. If you look at left hand side, it seems to be square of something to me. It seems to be square of something to me. It is actually sine square theta to the power 2 plus 2 sine square theta cos square theta plus cos square theta to the power 2. A square plus 2ab plus b square. A square, where a is sine square theta, b is cos square theta. So a square plus 2ab plus b square will become the square of sine square theta plus cos square theta to the power 2. In place of a, I have sine square theta. In place of b, I have cos square theta. If I square it, I'll get sine 4 theta plus double the product of first and second term plus cos 4 theta. So sine square theta plus cos square theta is 1. So 1 to the power 2 will be 1, which comes out to be right hand side. So from left hand side, again we achieved the right hand side. We were able to prove left hand side is equal to right hand side, and that is the basic problem in identities. You have to start one side and prove it equal to another side. Now let us see the fifth problem. Sine to the power 4a cosec square a plus cos 4a sec square a is equal to 1. I have just picked up very simple problems. You will be coming across much more complicated problem, but basic funda remains the same, that you have to use the known identities. You have to use the known identities. Now, it is sine to the power 4a. I can write it as 1 upon sine square a, because cosec and sine are reciprocal of each other. So if it is cosec square a, I can certainly write as 1 upon sine square a plus cos 4a, and sec square a I can write as 1 upon cos square a, because sec a and cos a are reciprocals of each other. Now it is sine to the power 4a and it is sine to the power 2a, so it will remain sine square a, left hand side, plus here cos to the power 4, cos to the power 2, so cos square a. So sine square a plus cos square a, 1. That is what we had to prove. So from left hand side to the right hand side, we are using the properties. And what are the properties? Generally the identities which we have learned till now, we are applying only those identities. Now let us see question number 6. Cos theta upon sec theta minus tan theta. Sec theta minus tan theta is equal to 1 plus sine theta. Now whenever, this is also a method, whenever you see sec theta minus tan theta or sine theta minus cos theta in denominator, sine theta plus cos theta, we are going to rationalize it. How do we rationalize it? You have learned rationalization in class 8. Cos theta, it is sec theta minus tan theta. I know sec square theta minus tan square theta is 1. I know sec square theta minus tan square theta is 1. So when we rationalize, what we do is we see the denominator and multiply the numerator as well as denominator by the, it is sec theta minus tan theta. You take sec theta plus tan theta. You multiply it by sec theta plus tan theta. Here also sec theta plus tan theta. So we have basically multiplied the question or the whatever the thing given by 1 only, because sec theta plus tan theta upon sec theta plus tan theta is only 1. Now what will we get? Cos theta. In the denominator, a plus a minus b into a plus b will give you a square minus b square. That will give you sec square theta minus tan square theta into sec theta plus tan theta. So what have we achieved? Because we have removed the denominator, because sec square theta minus tan square theta will be 1, we know that. So it will be cos theta into sec theta plus tan theta, because sec square theta minus tan square theta is equal to 1. This is basic identities, 3 identities which you had learned. Sin square theta plus cos square theta is equal to 1. Sec square theta minus tan square theta is equal to 1. And cosec square theta minus cot square theta is 1. Now let us open this bracket. Cos theta into sec theta plus cos theta into tan theta. Now these are reciprocals. So cos theta, sec theta can be 1 upon cos theta. Cos theta, tan theta can be written as sin theta upon cos theta. Sec theta, cos theta will cancel, cos theta will cancel. Here it will remain 1, and in the second it will remain sin theta, which is right hand side. We have to prove it to be equal to be 1 plus sin theta. We have to prove it equal to be 1 plus sin theta. So what we did was we rationalized it here. It was sec theta minus tan theta. We cross multiplied. We made it sec theta plus tan theta upon sec theta plus tan theta, and that is how we got cos theta upon sec square theta minus tan square theta into sec theta plus tan theta. Sec square theta minus tan square theta is 1. It remains sec theta plus tan theta. Then we multiply then cos theta into sec theta, cos theta into tan theta, cos theta into sec theta. Sec theta is the reciprocal of cos, so 1 upon cos theta plus cos theta. Tan theta can be written as sin theta upon cos theta. This cancel, this cancel. We got 1 plus sin theta. Now let us see question number 7. We have 1 plus cos theta minus sin square theta upon sin theta, 1 plus cos theta is equal to cot theta. Again the left hand side is more complicated. We will start from the left hand side. Now 1 minus sin square theta I can see should be equal to cos square theta. 1 minus sin square theta should be equal to cos square theta, because sin square theta plus cos square theta is always equal to 1. So cos square theta will be 1 minus sin square theta. So in place of 1 minus sin square theta, I'll replace it by cos square theta. I'll write 1 minus sin square theta here to make it more clear to you. Cos theta, left hand side, upon sin theta, 1 plus cos theta. Now 1 minus sin square theta is cos theta, cos square theta. Cos square theta plus cos theta upon sin theta 1 plus cos theta. Now out of cos theta I can take out cos theta common. If I take out cos theta common, I'll get cos theta plus 1 upon sin theta 1 plus cos theta. 1 plus cos theta or cos theta plus 1, both are the same thing. They will cancel with each other. What will you be left with? Cos theta upon sin theta. And cos theta upon sin theta is cot theta, which is you wanted to prove. You wanted this left hand side equal to cot theta. So what we did was, you saw what we did. We combined 1 minus sin square theta plus cos theta, sin theta into 1 plus cos theta. We adjusted the numerator only. 1 minus sin square theta is cos square theta plus cos theta. Sin theta into 1 plus cos theta. Out of this you take cos theta common. Cos theta plus 1. In the denominator I have sin theta into 1 plus cos theta. 1 plus cos theta, 1 plus cos theta cancels. I get cos theta upon sin theta, which is cot theta. That was problem number 7. Now let us go to the 8th problem here. Three minus 4 sin square theta upon cot square theta is equal to 3 minus tan square theta. Now we must look into the question also, that what we are trying to do. What are we trying to do in this question? Your answer is coming in terms of tan square theta. 3 minus tan square theta. While here it is on the left hand side, I have sin square theta and cos square theta. So somehow I have to get tan square theta in the numerator. That is only possible if I divide it by cos square theta and remove cos square theta from here. So let us see what we can do. Now if I pick up left hand side, what I am going to do is 3, along with 3 I will write sin square theta plus cos square theta. Because sin square theta plus cos square theta is 1. So it does not matter, 3 into 1 remains 3. But the things will change in terms of the shape of the question. Upon cos square theta. Now sin square theta plus cos square theta is 1. So 3 into 1 remains the same. Question has not been changed. But the structure of the question has changed to suit my getting the final answer as 3 minus tan square theta, because it will become 3 sin square theta plus 3 cos square theta minus 4 sin square theta upon cos square theta. Now 3 sin square theta is here and 4 cos square theta is there. So what will we get? We will get 3 cos square theta minus sin square theta. 3 minus 4 is minus 1. So I have got 3 cos square theta minus sin square theta. I will divide it by cos square theta. Now if I write it like that, 3 cos square theta upon cos square theta minus sin square theta upon cos square theta. I am dividing both portions of the numerator by cos square theta separately, because I can take the LCM. Now this will be 3 and this will be minus tan square theta. I wanted answer as 3 minus tan square theta. So you have to manipulate. It is all manipulation. In trigonometry, it is nothing but manipulation. You have to manipulate somehow. And you will say, how did you get sin square theta plus cos square theta? Once you start doing questions, once you start getting questions seeing questions of this kind, you will be able to solve it further question yourself. But you have to look into that. It is simple manipulation. Trigonometry solving is absolutely manipulation and nothing else. Now, the next question I have is cos A is equal to cot A upon cosec A is equal to cot A upon 1 plus cot square A. We have to prove this. Now, the question number 9, then he says third and A does not belong to third and fourth quadrant. What does it mean? What does it mean when he says it does not belong to? That means it belongs to first and second quadrant. In the first and second quadrant, first, second, third, fourth, it doesn't belong to third and fourth quadrant. It belongs to only second and first quadrant. In the first quadrant, all trigonometric ratios are positive. In the second one, sine and cosec are only positive, the rest are negative. So cos A, now let us take cot A upon cosec A. Cot A upon cosec A. Cot A means cos A upon sine A. It is cos A upon sine A. And 1 upon cosec A will become sine A. Cot A I have written as cos A upon sine A because tan A is sine A upon cos A. Cot A is cos A upon sine A. And 1 upon cosec A becomes as sine A. So this sine A will cancel and you will get cos A, which we wanted. We wanted it to be proved equal to cos A. The next is cot A upon 1 plus cot square A. Cot A upon 1 plus cot square A. We know cosec square theta minus cot square theta is equal to 1. We know cosec square theta minus cot square theta equal to 1. I am writing cosec square theta is equal to 1 plus cot square theta. You don't have to show it. I am showing it for you to understand. But you should know that 1 plus cot square theta is cosec square theta. So it will become cot A upon under root cosec square A, which is cot A upon cosec A, which is again the same thing as this was. And this will be equal to cos A. Because cot can be written as cos upon sine, and cosec will go as sine will cancel. You will get cos A as the value. So this is question number 9. What we did was, cot A I wrote as cos A upon sine A. 1 upon cosec A became sine A. Sine A cancelled, you got cos A. Then cot A upon 1 plus cot square A under root. In place of 1 plus cot square A, I can write cosec square A. Because 1 plus cot square A is equal to cosec square A. The under root of cosec square A will be cosec A. And cot A upon cosec A will again give us cos A as from the first step. Now let us see question number 10. In question number 10, I have sine cube theta plus cos cube theta. Before I start the question, I must have a cube plus b cube. A cube plus b cube has factors a plus b, a square minus ab plus b square. So we have to do the application of this because he is giving you sine cube theta plus cos cube theta. That means a cube plus b cube. A cube plus b cube should be applied to this as a plus b into a square minus ab plus b square. In place of a, I have sine theta. In place of b, I have cos theta. So here it is sine cube theta plus cos cube theta will be equal to what? It will be equal to sine theta plus cos theta. First a plus b, then a square sine square theta minus ab sine theta cos theta plus cos square theta. A plus b into a square minus ab plus b square. In place of a, I have sine theta. In place of b, I have cos theta. So sine theta plus cos theta into sine square theta minus sine theta cos theta plus cos square theta. It remains as sine theta plus cos theta sine square theta plus cos square theta will become 1 minus sine theta cos theta. This sine square theta plus cos square theta will combine to 1 and 1 minus sine theta cos theta, which is right hand side. We wanted to prove it to be sine theta plus cos theta into 1 minus sine theta cos theta, which is equal to right hand side. That is what the purpose of your thing is. Now let us see question number 11. Let us see question number 11. Let's see question number 11, which is cot A plus 10B upon cot B plus 10A is equal to cot A 10B. What I'll do is that I will convert cot A as 1 upon 10A. Let me write it as 1 upon 10A plus 10B. Left hand side. And this is 1 upon 10B plus 10A. 10 is reciprocal of cot, or cot is reciprocal of 10. So instead of cot A, I have written 1 upon 10A plus 10B. Instead of cot B, I have written 1 upon 10B plus 10A. Now when I take the LCM in the numerator, here I get 10A and I get 1 plus 10A, 10B. In the denominator, I will get 10B and I will get 1 plus 10A, 10B. Now, this 1 plus 10A, 10B, and here also it is 1 plus 10A, 10B, they will cancel with each other. What will you be left with? 1 upon 10A upon 1 upon 10B. And what is? You pick it up, 1 upon 10A will be what? Cot B, cot A, and 1 upon 10B will be what? It will go up. It will go up 10B. How? 1 upon 10A into 10B upon 1. 1 upon 10A will become cot A, and of course 10B will remain. So cot A, 10B is right hand side. 1 upon 10A, 1 upon 10B. We have to somehow eliminate. So what we did was we took LCM 10A. So I could see 1 plus 10A, 10B will be here. And similarly, if I write here 1 upon 10B and plus 10A, and if I take the LCM, I'll get 1 plus 10A, 10B. That you have to visualize. 1 plus 10A, 10B, 1 plus 10A, 10B will cancel. You will get 1 upon 10A, 1 upon 10B. 1 upon 10A into 10B upon 1. 1 upon 10A is cot A and 10B remains as it is. You will say, how do we visualize? You visualize by practice. The more questions you will do, the more you will learn about how to manipulate and how to do things. We are doing 14, 15 questions on one thing. You can do 30 questions more, or whatever number of questions you want to do to get well versed with this. Now let us see the next question, 12. Sin alpha upon 1 plus cos alpha plus 1 plus cos alpha upon sin alpha is equal to 2 cosec alpha. Whenever you're given things like this, that two things are there, added or subtracted, the first thing we should do is take LCM, left hand side. There's addition, so let me take LCM. 1 plus cos alpha into sin alpha. I've taken LCM 1 plus cos alpha into sin alpha. Sin alpha into sin alpha will be sin square alpha plus 1 plus cos alpha whole square. Now it will become what? Sin square alpha, and let us open 1 plus cos alpha whole square. It will become sin square alpha plus 1 plus 2 cos alpha plus cos square alpha. A plus B whole square is A square plus B square plus 2AB, or A square plus 2AB plus B square upon 1 plus cos alpha into sin alpha. Sin square alpha plus cos square alpha will be 1. So 1 plus 2 cos alpha upon 1 plus cos alpha into sin alpha. What have we done here? We have written sin square alpha plus cos square alpha as 1. We have written sin square alpha plus cos square alpha as 1. Sin square alpha plus cos square alpha I have written as 1. So 1 plus 2 cos alpha. Now it is 2 plus 2 cos alpha. So let me take 2 common. It will be left 1 plus cos alpha upon 1 plus cos alpha and sin alpha. 1 plus cos alpha will cancel. 2 upon sin alpha will become 2 cosec alpha. Your right hand side was 2 cosec alpha, because 1 upon sin alpha is cosec alpha. It's just the reciprocal of sine. So 1 upon sin alpha is cosec alpha. So your answer is 2 cosec alpha. What we did was we took the LCM, 1 plus cos alpha into sin alpha. Sin alpha into sin alpha gives me sin square alpha plus 1 plus cos alpha into 1 plus cos alpha will give me 1 plus cos alpha whole square. When I opened this up, it was already sin square alpha. It became 1 plus 2 cos alpha plus cos square alpha. This term will combine and give me 1. It will give me 1. Already I have 1 plus 2 cos alpha. So 1 plus 1 plus 2 cos alpha. 1 plus 1 will become 2, and 2 plus 2 cos alpha. So I can take 2 common. In the numerator I will be left with 1 plus cos alpha. In the denominator I have 1 plus cos alpha into sin alpha. 1 plus cos alpha, 1 plus cos alpha will cancel. It will become 2 upon sin alpha, which is 2 cosec alpha. This is question number 12. Let us see question number 13 now. Whenever we come across this kind of a question, like 3 brackets are there, cosec theta minus sin theta, sec theta minus cos theta, tan theta plus cot theta, just notice they are reciprocals of each other. Cosec and sin are reciprocal, sec and cos are reciprocal, tan and cot are reciprocal. So I'll change one of them. What I'll do is cosec theta I'll write 1 upon sin theta minus sin theta. Similarly, 1 upon cos theta minus cos theta and 1 upon tan theta as 1 upon cot theta plus cot theta. So when I'll take LCM, what will happen? All three brackets will have three different LCM. It is sin theta. It is 1 minus sin square theta. Cos theta will be LCM here. It will be 1 minus cos square theta. Here it will be cot theta will be LCM. It will be 1 plus cot square theta. Now all these are the basic identities. 1 minus sin square theta is cos square theta upon sin theta. 1 minus cos square theta is sin square theta upon cos theta. 1 plus cot square theta is cosec square theta. Cosec square theta upon cot theta. Now let us see what we can cancel. This is cos theta. This is cos square theta. So 1 power will cancel with this. Here it is sin theta. 1 power of sin theta will cancel. So it is left cos theta here. It is left sin theta here. And cosec square means 1 upon sin square theta. And cot theta means cos theta upon sin theta. So sin theta, sin square theta will cancel with this. Cos theta will cancel. We'll get the answer as 1. That is what we required. Answer is 1. Cosec theta 1 upon sin theta minus sin theta. Sec theta is 1 upon cos theta minus cos theta. Tan theta I have written as 1 upon cot theta plus cot theta. What we did was, we took the LCM in the first bracket, sin theta 1 minus sin square theta. Here I took the LCM cos theta 1 minus cos square theta. Here I took the LCM cot theta 1 plus cot square theta. And 1 minus sin square theta becomes cos square theta upon sin theta. Sin square theta upon cos theta. Cosec square theta upon cot theta. Now cos square theta is here, cos theta is there, 1 cos cancel. Sin square theta, sin theta, 1 sin cancels. Cosec square theta I have written as 1 upon sin square theta, and cot theta is cos theta and sin theta. So the terms cancel with each other. We get the answer as 1. Now let us see the 14th question, the last one in this chapter. There are many questions, but I will be solving these many questions. You will be practicing more questions, leaving these. 1 plus cos A upon 1 minus cos A is equal to cosec A plus cot A whole square. Now I need to get cosec A plus cot A. Cosec can be achieved by 1 upon sin A, and cot A can be achieved by cos A upon sin A. So what I am going to do is I am going to multiply numerator as well as denominator, divide numerator by sin A, divide denominator by sin A. It is 1 upon sin A plus cos A upon sin A upon 1 upon sin A minus cos A upon sin A. We divided this 1 upon sin A, cos A upon sin A, 1 upon sin A, cos A upon sin A. So you are dividing numerator as well as denominator by sin A, so you are not changing anything. 1 upon sin A is cosec A plus cot A, and this is cosec A minus cot A. Now we are coming to this form, cosec A plus cot A, but still we are a little away. What we are going to do, we are going to rationalize. That is cosec A plus cot A into cosec A plus cot A. In the denominator it was cosec A minus cot A. So I multiplied the numerator and denominator by cosec A plus cot A. It is cosec A minus cot A and cosec A plus cot A. So we are multiplying numerator and denominator by the same cosec A plus cot A, cosec A plus cot A. That means we are multiplying the whole equation by 1 only. So it will become cosec A plus cot A whole square, which you wanted as answer, upon, we are getting cosec square A minus cot square A. Why? A plus B into A minus B is A square minus B square. Cosec A minus cot A, cosec A plus cot A. So A minus B into A plus B. So it will become cosec A plus cot A whole square, and this will become 1. This is cosec square A minus cot square A is 1. So in place of cosec square A, cot square A minus cot square A, I'll get 1. So denominator gets 1 and numerator becomes cosec A plus cot A whole square, which was required to be your answer.